Hi everyone. Today we're going to talk about physical and chemical changes and physical and chemical properties. So this is one of the first lessons that we're going to talk about in Unit 1, which is called Matter and Measurement. So if we look at a very basic question, it says, what is chemistry? Now, if you even mention the word chemistry to some people, it brings up ill feelings of their own childhood experience in chemistry class. My goal is for it to never be like that for you. So one of the things that I aim to do this year is to make chemistry both enjoyable, fun, challenging, and hopefully not difficult, stressful, or any other negative connotation that could be associated with that word. So if you look up there, chemistry itself is pretty harmless. So it says chemistry is the study of the structure and the properties of matter and the changes that matter undergoes during chemical reactions. So if we just break that down a little bit, structure. So structure is basically how chemicals are put together, how molecules are put together, how atoms join each other to form molecules, and then those molecules and atoms can participate in the next part, which are chemical reactions, and they have different properties. So substances have different densities, different masses, different colors, textures, odors, things like that. So we'll talk about all of those examples as we go through this slideshow. So if I move on to the first slide, we're going to talk about physical properties. Now, if you look at the bottom there, I tried to just put some random examples. So if you're looking all the way on the left side, you have a picture of sulfur, powdered sulfur. If you look in the middle, you have a bottle of what looks like Chanel cologne or perfume. And then all the way on the right side, you have a thermometer that is sitting in a glass of ice water. Now, what those are meant to illustrate, obviously as the slide heading tells you, are physical properties. So let's take a look at what physical properties are. So it says physical properties are characteristics that can be observed or measured without changing the composition of matter and are used to observe and describe matter. So if you look at all three examples that I have on the bottom, you can make those determinations. So solid, sulfur, powdery, yellow, all of those things that I talked about just now are all considered physical properties because they're all things that you can observe without changing the substance. Same thing with the perfume or cologne in the middle. It has an odor. You're able to observe that without changing the substance. And then all the way on the right side, the temperature of something. So regardless of what phase of matter it is, if you're able to measure its temperature, you're not changing that substance per se. So that's got to be a physical property. So if you look, I put as examples include appearance, texture, color, odor, melting point, boiling point, density, solubility, and polarity. So going through those, appearance, what something looks like, texture, obviously what it feels like if you were to touch it. Sometimes we have powdery materials like sulfur in this case, but also we have smooth material like metals. Color, obviously, odor, what something smells like. Now, some people want to make the argument that melting point and boiling point are probably not physical properties because they're observed through a type of change, but the change that they undergo, so if we're talking about melting point going from a solid to a liquid, or if we're talking about boiling point going from a liquid to a gas, those changes aren't changing the substance. So water as a liquid and water as a gas, that's both water. So it's the same substance. So it's not considered a chemical change in that case. And then moving on, density, we're going to talk a lot about density. So density is the relationship between mass and volume of a substance. Solubility is how well it dissolves and what substances it's able to dissolve into. And then we're going to talk a lot this year about polarity. So polarity basically is a measure of how symmetrical a molecule is, and the polarity of a molecule determines how it behaves. So its symmetry, so whether or not we'll call these terms polar and nonpolar, so whether or not the molecule is polar or nonpolar will determine how it behaves when it participates in chemical reactions, when it bonds with other things. So I mentioned chemical changes kind of ahead of time, but I wanted to back up a second and talk about physical changes. So if you look at the two pictures that are here, there are two physical changes. So on the right side, you have a picture of, it looks like ice melting in a pot, or maybe even water boiling in a pot, depending on what state of matter that's going toward. And then on the left side, you have just someone chopping up some parsley or some basil maybe for meal preparation. So in our cases, we're going to call physical changes as changes that affect the form, so the size of something, maybe the temperature of something, but they don't form a new substance. So it's not changing its chemical composition. All right, that's a lot in 2 slides there. So what I'm going to do is just ask you if you have any questions so far to just jot them down on the side, and we'll move on to the next slide right after this. So it says examples include, so these are things that you can do to a substance, but you don't form a new substance by doing this. So heating and cooling, chopping, breaking, even dissolving. And we're going to talk about something like dissolving salt in water. Why is that a physical change and not a chemical change? Well, you can easily boil off the water and you'll get back your salt and your water. Water will be in the gaseous form at that point, but you didn't form any new substances. So no chemical reaction takes place when you take salt and you add it to water. So now we talked about physical properties, then we talked about physical change. Now we're going to talk about chemical properties followed by chemical change. So if you look at the screen here, I have 2 pictures. So I have a picture of a chemical reaction. We will come to find out that CH4 is called methane. In this chemical reaction, methane is reacting with oxygen and it's forming carbon dioxide and water. And I also have a picture of the symbol that usually you might see on the outside of a tractor trailer that's carrying flammable liquids in it. So this is a symbol to indicate that something's a flammable liquid. So if we look at what chemical properties are, it says chemical property is any of a material's properties that become evident during or after a chemical reaction, a trait that is only observable by forming a new substance. So in this case, methane, when you come to class, if you work in a lab, they're going to have gas jets on the desk. You could see some behind me. Those gas jets have natural gas coming out of it, which is mostly methane. So methane, in this case, is a flammable gas. It reacts with oxygen, it produces a flame, it gives off an immense amount of heat. But here's the trick. You can't look at methane and tell that it's flammable. So this is a characteristic, a property, if you will, that is observable only through a chemical change. So only by taking methane and combining it with oxygen and igniting it do we get our products of carbon dioxide and water, and only that way can we tell that methane is a flammable gas. So here are some examples. So they include flammability, explosivity, energy of formation, oxidation states, bonding. How things bond is a chemical property. It's observed only through a chemical change. Okay, if we go on to look at chemical changes, so down at the bottom here, again, I have 3 pictures. So the first one just looks like a piece of wood burning. The second one looks like maybe a rusty kind of part to like a treasure chest or something. And the third one's kind of gross. So that is some curdled milk sitting in a glass. So chemical changes occur when a substance combines with another substance or when it decomposes, forming one or more new substances. So some examples of this include burning wood, milk souring, as you see below, acid-base reactions, digestion, that's a chemical change that occurs in your body, and then rusting, like you see in the middle picture. So now we have to talk about how to know whether or not a chemical change has occurred. So it's pretty easy to figure out whether a physical change has occurred. So if you take a piece of chalk and you obliterate it into a powder, you know that's a physical change. If you take a piece of paper and you tear it in half, if you take a log and you chop it up, if you take water and you boil it for pasta, all of those are evidence of physical changes. But how do we know if a chemical change occurs? Because sometimes it's not as obvious as something burning or something exploding. So there are 4 ways to tell. So the first one is the formation of bubbles. So if you think back to your elementary school or perhaps middle school experience, where you combined acetic acid, which is vinegar, and baking soda, which is sodium bicarbonate, and it foamed up and bubbled all over the place. That is an example of a chemical change. That's a chemical reaction that has taken place. Second one is the formation of a precipitate. So for most of us, precipitate might be a new word. You might have heard of precipitation. So when it snows or rains, things that are falling down from the sky. That's kind of a good analogy to think about, because when you form a precipitate, you're forming a solid. And if you are doing that in a test tube or something, or a beaker or Erlenmeyer flask, and we'll talk about all of those things, you'll see that solid fall to the bottom. That is a precipitate. So it's a solid that results from a chemical reaction, and it could be between two liquids. So I'll show you examples of that when we talk about our physical and chemical changes lab. The third way to identify a chemical change is by a change in color. So this picture that's kind of in the middle here, showing a person swirling that triangular shaped glass vessel, is called an Erlenmeyer flask. So someone swirling an Erlenmeyer flask, that's called a chemical, or that's a chemical change. In this case, it's changing colors. So you start to see that pink color starting at the top. And then finally, and you can kind of get a sense of what it is by looking at all of these pictures that are up here. So we had an example of the bubbles up here. We have an example of the formation of a precipitate, a change in color, and now a thermometer. And that's because our last way to tell whether or not a chemical change has occurred is by looking for a change in temperature. So change in temperature could be temperature going up, or it could be temperature going down, depending on what type of reaction is taking place. So what I want to do now is, let's go back a few slides and look at these chemical changes down here. So in the first one where you saw the wood burning, that's obviously a change in temperature. The second one where you saw the rust forming, so you notice it by a change in color. Rust is sort of a precipitate that forms. Same thing with the souring of milk. That's a new substance that forms that has a different consistency than the milk did originally. But these are the clues that you look for when you're trying to decide whether or not a chemical change has occurred. So what I would like to do now is let's take a look at some examples. So if you look at this, and if you are able to open up the Pear Deck of this presentation and kind of follow along as I'm giving you this video, you'll see some examples here. And in the first one, it says, in trying to identify a sample of a pure substance, we observe the following properties. Tell whether each one is a chemical property or a physical property. So the first one says a substance has a mass of 124.3 grams. Do we think that's a chemical property or a physical property? So hopefully you came up with the answer of physical. So you can measure the mass of something without changing it, right? So if you wanted to weigh out an ingredient, let's say that you're using to bake a cake, and it tells you that you have to weigh out a certain amount of it. You can do that using a scale. That ingredient does not become a different substance by placing it on that scale. Let's look at our second example. It says silver is a shiny solid at room temperature. So again, this is something that you can observe without changing the substance. So again, we would classify this as a physical property. Let's look at a third example. It says glass is easily etched by nitric acid. So nitric acid interacting with glass, this is actually going to be a chemical property, because this is not something that is easily done by other substances. So if you took water and placed it on glass, it's not going to etch the glass. So what you're looking at here is a chemical reaction that occurs, and that is a result of a certain property that nitric acid has. Nitric acid, we'll learn, is a strong acid. So it's a property of nitric acid that allows it to etch glass. Next one. Says a professional football is 27.94 centimeters long, and I hope it is, because that's what I Google searched before I typed that in. So hopefully a professional football is about that long. I believe that was about 11 inches, and then I converted it from English system to metric. So we're going to all learn how to do that later. But professional football is 27.94 centimeters long. Is that a physical property or a chemical property? So if you said physical property, you are correct. By the way, just putting this out there, if the video looks choppy at all, sometimes I have to pause the recording to get some water, so just letting you know. All right, next. It says aluminum is a good heat conductor. Now, think about things that conduct heat well. So you put a pot on the stove to boil water. It's made of metal. Metals are good conductors of heat. Aluminum is a really good conductor of heat. So if we think about the fact that the substance is not changing, aluminum is not changing when we heat it, right? So if we put, let's say we had an aluminum pot, we put a substance into our aluminum pot and we heated it, it's transferring that heat energy from the stove top into the whatever water, let's say, that we're boiling. So that is a physical property of aluminum. It does not change during that transfer of energy. So physical property, if something is a good conductor of heat. That's different than saying heat is given off as a result of a chemical reaction. Okay, next one. Ethanol burns in the presence of oxygen. You've probably heard a lot about ethanol lately. Ethanol is the ingredient, it's an alcohol, so it's usually the ingredient in a lot of sanitizers. They have to have a certain percent ethanol in order to be considered for that process of sanitizing something. So something like Purell has like over 60% ethanol content, alcohol content. All right, it says it burns in the presence of oxygen. Here's an example where just looking at ethanol, you are not able to decipher whether or not it burns. It's like looking at a can of gasoline that you might use for the lawnmower in the backyard. You can't look at that container of ethanol, in this case, or gasoline, and know that it's flammable. It's only after it undergoes a chemical reaction that you can actually observe its flammability, its characteristic. So ethanol burns in the presence of oxygen. That is a chemical property. Next one, silver is a good conductor of electrical energy. So metals in general tend to be good conductors of electrical energy. Silver is a really good conductor of electrical energy. Someone asked me one time in a class, oh, well, how come we don't use silver for our house wiring? Well, because it would be extremely expensive. So instead, we use copper wiring because copper is a cheaper metal, but both are good conductors of electrical energy. So you don't have to think too long about this to realize that if silver is a good conductor of electrical energy and copper is a good conductor of electrical energy, and they're used in wiring in your houses, my guess is that that has to be a physical property. It's not going to be a chemical property because the first time you turned on a light bulb or the toaster, if that copper changed into something else, that wouldn't be really beneficial to us. So the fact that silver is a good conductor of electrical energy or copper is a good conductor of electrical energy, that's going to be a physical property. Okay, so that is our last slide. There is an activity for you to try on physical and chemical properties. You can find that in the assignments folder on Schoology. If you have any questions, please reach out to me at any time through Schoology Messenger. You can also email me, but Schoology Messenger is also a great way since I pretty much am on Schoology all the time now. So it was very nice sharing this time with you, and I will talk to you soon for our next lesson. Thanks very much. See ya.